So we'll move back onto a CB. It's Wednesday. I've got to look at the time. I've got Mrs. Ex-Nurse to do some shopping for one of our elderly parishioners. I do get paid for these shopping jobs. So, I think we've got about 20 minutes. So I bought this Midland off eBay the other day. And it was top whack. It's a 77 1165. And this is one of the more unusual ones. And I think it was probably about 1987. And I would think I've only ever seen one once before. I did pull the circuit and layout off the internet. Oh, here comes a date. August 87. So my theory's right out the window. I could press the manual focus button. Manual focus. Worse. About as good as we're going to get. So August 1991. Serial number 338. The high-low power switch is on the back. Now I regard this as top whack plus, but I wanted to do a demonstration on one, so I bought it. Go back to autofocus. Press that button there. Hey. Return to automatic position 1. Done. Okay. So we have this. I'll take the side screws off. I'm glad we got the mic with it, because it's a side mounting 5-pin DIN. And it comes with a right angle connector. So we'd have put a standard one on, and of course it's then poking out to the side. We use those metal Nutrix ones, if you remember. So we've got the factory original microphone, and this is why I've ended up paying top whack. Now I'm going to just cross out the person's username, because that's not fair to them. And so I have paid an eye-watering £30 for this. Hey, gone are the days that I was paying £1.07 for broken CB radios. And before we go over the page, it's come from Glasgow, and for some reason he's asked for £9.02 postage. So he's chosen to send that first class. So had it been second class, the cost price to him would have been £3.20. I don't know. Don't get it. Anyway, it had to be paid, didn't it? It's not how to get maximum feedback points so on postage, is it? So we've got the blurb here. CB radio, Midland model 77099. No. It's 1165. Fully tested, 100% working. A brilliant Wii radio, there's some good Scottish, in mint condition. Well, quite. In full working order. Power lead, great reports using this radio from local breakers. That means nothing. And very good on receive too. In great condition for its age, and very unusual screws. Oh, it probably means the side screws. Grab this lovely example of a classic mint condition Midland radio while you can. No returns due to screwdriver warriors and part swappers. Well, don't we know that? So we'll test this as presented. But I feel confident that we're not going to have any. It's not going to be faulty, is it? It's not a Midland 099. It just makes me wonder whether he's just used another somebody else. No, it's his wording with word like we. I don't know. It's not an 099. So we'll connect it to our trusty power supply with our trusty short-circuitable crocodile clips. But I have to learn to speak proper like what everybody else does. I will just loosen. Oh, they're the unusual case screws, which are annoying self-tappers. I'll take 3 out of the 4 out, but I won't take all 4 out because I want to do a test before poking my face inside there. So connect that up to the test set. And yesterday we were doing 77s amateur, wasn't we? So we're going to have to turn the equipment back to 27 megs, which I will do. I did say the other day we've got a President Taylor 3 on the shelf, and was anybody interested in seeing that? And somebody said yes. So I'll try and get that in tomorrow. Remember, we've got no on-the-air test. This won't get on-the-air tested till Mr. Chippy gets back. So there's not going to be any on-the-air tests. So we try and do things which don't need that. I must finish off that homemade ham radio alignment, which I did on my... was it 3.5 megs? I can't even remember what it was, but the one where I've got power supply and the transmitter I built in the 80s in green. Anyway, I finished that off. I did the receiver alignment. It's in the memory card. I just need to do the transmitter alignment, which is much easier than the receiver alignment, which I always do the hard thing first. Right, so let's plug that microphone in. So this stands me at £39 something, which will be more than the trade price of it when it was new. Right, power supply on. 13.8 volts. Radio on. Boots up on channel 9 because it's annoying. Oh, it's got the 9 switch in. Channel 20 selected. We'll select picture in picture, and then you can see the power meter. I'm going to put the power meter onto 3 watts full scale deflection. So if it swings right across, we've got 3 watts. It swings more than that right across. Just doing 3.2 watts. And before we go any further, we'll put it into our Zetagi meter, which will be the kind of thing, if the vendor says he's tested it, if he's got a meter at home, it's more likely to be a hobby meter than part of a multi-thousand-pound laboratory instrument. So I'll put the dummy load in the Zetagi meter because we're showing that even more ridiculous Bremy one yesterday. If you remember, we did, it wasn't yesterday, it was the day before, we did that President Barry, was it? And it was 4 watts on the test set, 5.5 watts on the Zetagi meter, and 8.5 watts on the Bremy meter. So we know this is 3.2 watts, and it's just over the 4 on the Zetagi meter. So we'll look at deviation, which I will just have to tune the system in because we were on UHF yesterday. Wallow. 1 to wallow. He's actually about right. Just needs to pop up a fraction. That's really good. So it should be 27,79125. It's pretty low, that. Still within tolerance, but it's pretty low. So that needs pulling up. And now we'll look at receive. So let's see what that sounds like. And we'll see what it looks like on the sign-on meter. So for 12 decibels, it's doing 0.35 microvolts. So that's very healthy. So that's good. Let's see where S9 is on the meter. There's S9. It's reading S5. But that's all rubbish anyway, isn't it? Yeah, it's pretty daft. And when I press transmit, how many? It all lights all 4 up. Fair enough. Okay, well, it certainly works fine, just as he says it does. But of course, our job here is to optimize radios, and this doesn't work any worse than it could do as a brand new set. So that's fair enough. It's a few years old, it's dropped slightly, but it's not off frequency, it's within tolerance. Glancing at the clock with 10 minutes. There's a pluggable speaker on this, which is good news. I don't like this C5121 synthesizer chip, which puts it on channel 9 every time. In actual fact, the presets are labelled. That's absolutely great. So what we need to do is we need to start off by doing the transmit frequency. So we've got the trimmer there. So we'll go to there. We want 27.79125. To do everything but. I think that's as near as damn it. Okay, so we've done that. We need to now address the power problem, so we'll go automatic power control. Do we need the metal tool for this? Do we know where we've hidden the metal tool? We used it yesterday as a probe. There we are. So he's now 4.1 watt. So what we now need to do with it on full power, should have shown you that on the camera. So you can see it's not being messed with. It's 4.2, 4.3 watts. Just need to make sure these are all peak. Use a ceramic tool. Peak. And then we'll go to that. Like there. This will be the trap. I'll put the spectrum analyzer on. So that's anything past the PA transistor is going to be the 54 megasecond harmonic trap. So we'll now pop this down to 4 watts. So it's doing 4.4. And we'll do the low, just check the low power. Should be 400 milliwatts. It's 170 milliwatts, so that'll be power low. And that's 400 milliwatts now, which is where it should be. Switch that back to high power. Of course, it's exactly the same place on my meter, because 4 watts is of course one under the 5, and on the 3 watt scale 400 milliwatts is one under the 0.5, so it looks like it's the same. Okay, so we'll put the spectrum analyzer on into, we'll just loosely couple it. Press auto, see what happens, and we'll go over to the spectrum analyzer on here. And we've got, oh, I'll have to stand up. 250 megs? Right. Why did it pick that out of all the frequencies? I'm sure there's not a huge harmonic. So there we are, 2779125. So now we need to find our second harmonic. Oh, I need to dial in 54 megs first. Frequency, I'll put 55 megs in. There's our second harmonic. Mark it, peak. It's minus 53. It's supposed to be minus 54 or better. So I'm sure the government inspectors aren't going to come round for that. But you know, I can't feel those. They're not actually adjustable. They have cores in them which are in a preset position. So there we are. That's how it is. So what we could do is to adjust this so that's now improved it. It's now, oh no, that's made it worse. So now look back at the power. So by turning the power up, I've now got a cleaner signal, which is something that can happen. So we'll just turn it down now on here. Yeah, we're there now. And we'll just recheck low power. So I've had to turn the power up on the radio and down on the power preset. Okay. And there's a delivery. Oh, that was UPS with some more steel shelves from the for our shed, which we're putting things in. things out of the way because of the building work. It's one of those Canadian plastic sheds, which is what, 16 by 11 feet. So it's the working height, which is excellent. Right, it's more substantial than you think as well. It's all steel framed. Where were we? So we've done the power. We want to do the power meter. Well, we don't want it to read 4 just because it reads 4. So if it's got an RF meter, signal meter, squelch, deviation. That'll be TX then. So where the word whoops, and I've changed channel as well. So to be that one. So it needs to be just 4. No, we can't do that. So we'll just turn it down, and then. So that's supposed to be 1 bar, but it's 2. So that's as aligned as we're going to get it. Deviation. Well, only wanted just touching up. So it was 2.1, so we'll just bring that up a fraction. Voila. That's fine, done. That's transmit done. And we're out of time. Actually overshot it by a minute. So I'll carry on with this afternoon, and at least we've done the transmitter in its entirety. Right, it's 10 to 1. We'll see whether we can wrap this up. We've done the transmit, so we'll move on to receive. And I'm again looking at the time because I need to be at a church to have a problem organ-wise. It's one of these. It's older than most organs. It's because most of the organs I see tend to be in the kind of 1870s to 1898 type of area, but this organ's 1840s. And if I said to you it needed an overhaul probably 70 years ago, it keeps plodding on anyway. Well, because the churches have been out of action with the COVID for a bit, and they've come back and there's lots of notes sticking. So I was going to see, this is just a courtesy visit. They're only 4 miles away, and if I can do it without any tools, just with my skill of my hands, then there'll be no fee. So let's have a look. We want to reset the signal generator because it's had a little bit of a wander. So the first thing we'll do is we will look at the oscilloscope. Turn the bench light off to make that a bit more visible. And guess that that's going to be the detector or demodulator. You know what? It isn't. It must be that one then. You know it's not. What about that one? It's not that either. So we've got... Oh, it's that one! It is. There we go. Right, that's with an S9 signal, so we'll now drop the signal generator. There was no need to adjust that, it's just part of the procedure to make sure it's spot on. So we'll go over to the synad meter now and we'll tune it up on a synad. So we'll start with the front end. Just drop the signal to about there. Nicely peaked. Peaked. I can actually feel that one's actually broken. But I can move it enough to see that it's at the peak. There's a crystal filter there. Right, we'll just look at these IFs and just see whether we can optimise them. Especially after I've disturbed them all. Sometimes you need a bigger signal. Well, I think we're there. I'll just go and recheck this previous one. Some interactivity with some. Right, let's see where we are now for 12 dB. Ooh, not quite at 0.3. .35, no difference whatsoever. So it was spot on, and that's great. So we'll go back to an S9 signal. I'll switch the attenuator onto the screen. So we want the third one to light. There we are, and if I turn the signal up on the signal generator, it goes up and we can go down. So here we have the 4 bars. So now it's the squelcher's turn. So we'll turn the squelch to full, the signal generator to 100 microvolts, and we want that to now come in, and it doesn't. So that is out of adjustment. I am doing the right one, aren't I? What a wally. We'll reset the deviation in a moment. That's the squelch. That's fine, that's exactly where we want it to be. Now we'll check the sensitivity at the other end. So we've parked the signal generator at 0.3 microvolts, turn it off, which we've done, set the squelch to threshold, switch the signal generator on, straight in. Wow, that's good. Just have to give it another go. We'll get there eventually. It's coming at 0.3 of a microvolt, it's going out at 0.12 of a microvolt. So that's really, really good. Okay, so now we'll just reset that deviation after I've been a silly Billy. Wallow. 1, 2. There we go. So is Harvey Young the manufacturer? I don't think we've got anything left to do now. We're done. Okay, I'll put it back together. So the vendor was absolutely right. It was in good working order, and we've made a few adjustments. Pulled it up on frequency, but it wasn't out of alignment. It wasn't, you know, it just drifted down with age, but it wasn't so bad that it would malfunction. Pop the deviation up a little bit. Pop the power up a little bit. But he was right. It's a good radio. What we won't be able to do, of course, is an on-the-air test with Mr. Chippy till he gets back. So this will be put on one side for a couple of weeks, and then we'll probably do a couple of on-the-air tests today when he gets back, if they let him back. So all we need to do now is to put the aerial on it and see what kind of buddies are out there, whether there's any good ones or any bad ones. Let's just check this fuse. 2 amp, that's exactly as it should be. Nothing tarnished in there. Oh, it's a fluttery, nasty squelch, that. "19 Roger." "1 on the Roger." Okay, that's it. Midland 76. Or is it 77? 77 11 65. Oh, I'll tell you what we never did do. I'll tell you what would be interesting just before we wrap this up. We'll put it back on the test set, and we'll see whether this is how affected by voltage it is. So we're at 4 watts. We'll go back to there. Pop it down to channel 20. So it's doing 4 watts. So we'll turn the voltage down to 12. It's doing 3.5 watts. 11.6. It's doing 3.25 watts. And if we go beyond 13.8, it starts to 14, and we start to go into 4.2 watts. So it's quite affected, but not as bad as some. Right, thank you for watching, and so we'll do a video of it on the air with Mr. Chippy when he gets back in a couple of weeks.